Can we write and solve proportions to solve problems?
Yeah.
We've been writing all kinds of proportions, right? And we're going to do it some more today. So this was our objective for 6.1, and it still applies for 6.2, and the rest of these we're going to be continuing to work throughout the rest of chapter 6. So writing and solving proportions, we're going to keep on doing it. Similar polygons, that actually doesn't come until probably 6.3, but we'll eventually get there. Today, just like our objective says, we're going to use proportions to solve geometry problems. The first property, which is from 6.1, is the cross products property. What's the cross products tell us to do? Cross multiply, right? The new one for today is called the reciprocal property. The reciprocal property says if two ratios are equal, then the reciprocals are also equal. Fill that in your blank. If two ratios are equal, then the reciprocals are also equal. What's a reciprocal? When you flip it upside down, right? A reciprocal is when you flip it. So if I give you this, and you should write this down as well, if A over B equals C over D, then if A over B equals C over D, then when I find the reciprocal of each of those, then I say B over A equals, what, Matt? Good. D over C. That's the reciprocal property. A over B equals C over D, then B over A equals D over C. Property 3 says this: if you interchange the means of a proportion, then you form another true proportion. Fill this one in. If you interchange the means of a proportion, then you form another true proportion. What's interchange mean? What do you do? You change them, you swap them, right? If you interchange the means, we're going to switch them, then you form another true proportion. So if A over B equals C over D, what are these called? The extremes or the means? The means. One of those two. This is our means, right? And what would these two be called? These are our extremes. And you know how I remember that? This is my extremes, and that's my means because E comes before M in the alphabet. Right? So if I interchange my means, these are my means, so I'm going to change them. I'm going to switch them. Yeah? So what does that look like? If A over B equals C over D, then A over C equals, good John, B over D. C comes down here, so A over C equals, then B goes in its place, B over D. And property 4, in a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. If you add the value of each denominator to its numerator, then you form another true proportion. So here we go. If A over B equals C over D, then this is what happens. I take what's in the denominator, and I just add it to the top, and I keep everything else the same. So I go A plus B, still over B. So what's in the denominator, we add to the top, so A plus B over B equals C. It's still C over D. So take from this denominator, C plus D over D. So here, in this diagram, Mn to Rs equals Np to St. Right, 4 true proportions. The first proportion I'm going to write is filling in the blanks of the original one that they give me. So my first one, what is Mn when I look at the picture? 8. What is Rs? 10. What is Np? NP is 4, and ST is X. This is the first one, which is just like that. The second one we're going to do, I'm just going to make a note. Let's do the reciprocal property. What's reciprocal tell us to do? Flip it. So I'm going to take the original one that I just wrote here and I'm going to flip it. What's that look like flipped? 10 over 8 equals X over 4. Good, Brent, Courtney. So I took the original and I wrote the reciprocal. My third one, let's do the means. Let's interchange the means. Where are my means at? 8 and X or 10 and 4? These are my means. So I'm going to switch them. So 10 is going to be over X and 8 is going to be over R4. So I used the original. I used the original one again. And my fourth one, this is the one where we add the denominator to the numerator. So if I have 8 over 10, what do I add to the top? If we have 8 over 10, what goes here? 10. And that equals, I had 4 over X, 4 plus X, whatever's in the denominator on that side, add that to the top. All 4 of these are the same. Watch what happens. Well, how do we solve this, first of all? Cross multiply, right? 10 times 4 is 40. 8 times X is 8X. When we solve, X is 5, right? Look here. What's 8 times X? 8X. 10 times 4, 40. X equals 5 again, right? So far, those two are the same. Look here. 8 times X is 4 times 10, 40, X equals 5. Number 4, yuck, there's no way that's going to work out. What's 8 plus 10? Can I simplify this first? So can I go 18 over 10 equals 4 plus X over X? Now cross multiply. This one's easy. 18 times X is 18X. Brent did it already. I'm going to write it this way just so we can see it though. It's my 10 times my 4 plus X. Brent says 10 times 4 is 40. 10 times X is 10X. That doesn't look like that one. How do I solve for X? Subtract your 10X. Look at that. 8X equals 40, so X equals 5 on all 4 of those. The way I set a problem up and solve it might be different from the way Courtney sets it up and solves it, which might be different from the way Justin sets it up and solves it. But if we follow these rules, we're all going to get the same answer, even if we do it 4 different ways. Look at this one. In the diagram, JL to LH equals JK to KG. Find JH and JL. So I'm just going to start here. JL. Do I know what JL is? Well, X is from J to H, right? This is 2. What goes here? This is 2. That's not going to be 2, 2. I don't know. So let me lead you this way a second. If I give you this line segment, I'm going to tell you this whole length is 15 units, okay? If that whole thing is 15 units, and from here to here, let's say this is 3, how big is this? 12. How'd you get 12? We subtract. 15 minus 3 gives us 12, right? Does that make sense? It's all 15. I subtract the 3 out, and that gives me 12. So watch this. I know it's not a number, but I know from here to here is X, right? I need to subtract this 2 out, and that's going to tell me what it is from J to L. This is X minus 2. The whole thing is X. I subtract that 2 out, and this is X minus 2. Yeah? Are we okay there? So tell me again, how big is JL? We just said it is X minus 2. JLH, 2, JK, 15. I've got Brent, I lost the rest of you. KG, 5. Can we solve for x? Can we cross multiply? It's got a minus in here, so we can distribute. We can go 5 times x minus 2 equals 2 times 5, which is, or 2 times 15, I'm sorry, which is 30. Distribute 5x minus 10. Add your 10. Are we getting this on our paper? So 5x equals 40, and x is 8. So find JH and JL. So I say, well, what's JH equal? JH is the whole thing, right? Which is x. So if I plug in my 8 here, what is JH? 8. And then it says find JL. Well, where's JL at? Right here. It's x minus 2, right? My x value is 8, minus 2 gives me 6. JL is 6, JH is 8. How about this one? In the same example, now I know this, and I want to find GH. What's KL? 12. GH, well, that's what we're trying to find. So I call it X. JK, 15. And JG, 20. JG is the whole thing. So we go back to chapter 1. We do our segment addition. 15 plus 5 gives us 20. Then you cross multiply. 15 times x, 12 times 20, 240. Good. Divide by 15. X equals 16. So check this out. What do we know? GH is equal to our x, right? And if I were supposed to find GH, it's the same as x, so GH is also equal to 16.